All right. All right. So this one says first to simplify. So this is going back to like day 1 of this chapter. There we go. Where what we need to do is we're going to need to factor both top and bottom here. So if I look at my numerator, what's going to be my first step when we're trying to factor this? GCF. This is a GCF of 2. So I could rewrite this as 2 times x squared plus 5x plus 6. And then we can factor this part using our x frame, where we take our a times c at the top, which is 6, and our b at the bottom, which is 5. What is a pair of numbers that multiplies to make 6 and adds to make 5? 3 and 2. I got it, girl. You got the little pass? Okay. So when we put this into our factored form, our numerator is going to become our 2x plus 3, x plus 2. So we're factoring this, and we round up over here. Then we're going to take this one and factor it. Very similar. This time it doesn't have a GCF, so we're just going to hop straight into our x frame for a pair of numbers that multiplies to make 2 and adds to make 3. 2 and 1. So we have x plus 2, x plus 1. And what can simplify here? The x plus 2's can cancel out because there's one on the top and one on the bottom. So our simplified answer is 2x plus 3 over x plus 1. Questions on that one? Okay, we are going to head in a very different direction today. It's going to feel very different, but I promise it's related. There are going to be several things you need to write down, so you're going to want your notebooks out. Because we're going to talk about something called variation. And we're going to have 3 different kinds of variation. We've got 2 written on this page. So our first one is our direct variation. And what those are going to look like is they're going to look like equations that look like this. Y equals some number times x. So it looks like a linear equation. We're also going to have joint variation. When one quantity varies directly as the product of 2 or more other quantities, the equation looks like this. So these phrasings while awkward, are going to be kind of important to what we're doing. When one thing varies directly, so that means y varies directly. So it's going to be y equals x times some number, or k, or some number times x. So the way we're going to be given problems on these is it's going to be like a sentence. It'll say something like, when y varies directly as x, find x when y is 12, or whatever. So they're kind of awkward, but we're going to need to know, oh, sorry, my thing. These and these, that the direct connects with this, and joint connects with this, and we're going to have one more when we get to the, after we practice these two. So this is the kind of problem that we're going to have. Don't worry about this. This is for if we were working in the book, but we're not, because the book is stupid. What's up? Yep. So we're going to be using these for all of today. Okay. I'm going to change it in 5, 4, 3, 2, 1. All right, so here's going to be our first example of a problem. It says if y varies directly as x, means we know we're going to use our direct, whoa, that's not the highlighter. This is the equation we just wrote for varies directly. And we know that y equals -3 when x is 24. So we're told this information. We are asked to find y when x is 16. Oh, those are too close together in color. I don't like that. Blue. So there's really 3 sets of information we need to know here. When y varies directly, we know we're going to look for this equation. They're going to give us some values so that we can figure out k. We need to know our constant k. So if I know that y equals -3 when x equals 24, we're going to substitute those into this equation. So we know that y equals -3 means -3 equals some k times x is 24. How can we figure out what k is? How can I get k by itself? It's like we're going to divide because they're currently being multiplied. So if we divide both sides by 24, (3 divided by 24), that will simplify. So we can actually find out that our k is -1/8. You just want to put the pack on my desk. Thank you, dear. Yeah, I'll just put it on my desk. I'll make sure it gets into the system. So now I know my K, and I'm going to come back up here to my original equation and bring it across. So now I know that this relationship can be expressed as y equals negative 1/8 x. So we took this information and used it to find K so that now I can figure out my answer over here. If I want to know what y is when x is 16, what am I going to do with this with the negative 16? What could I do with this? Plug it in. We're going to substitute it in for the x down here. So we're going to have our y equals negative 1/8 times negative 16. Negative 1/8 times negative 16. Negative times a negative is a positive. So 16 divided by 8 is going to be 2. And that's my answer. So there's a lot of weird in-betweeny steps. The questions on the first one we've done like this. We will always tell you how it varies in these kinds of problems, and we'll give you enough information to figure out K so that we can find another value. Okay, let's try a jointly. So now we have that y varies jointly as x and z. That means we're going to use that y equals k, x, and z. So since it says it varies jointly, that means y is on one side as these guys are joined together, x, z, and some other number. kxz or xzk, I don't really care what order it's in, it doesn't matter. So then they tell us our goal is to eventually find y when x and z are these values. So that's our goal, is to get there. We're told that originally we know if y equals negative 15, x equals negative 6, and z equals negative 1. So we start with the trio that I know everybody. Those three work together. My 15, negative 6, and negative 1 are 1 unit. So we start with putting those pieces in order to figure out what k is. So I'm going to start with my y equals minus 15. Equals some number k. We don't know it yet. When my x is negative 6. And my z is negative 1. So let's simplify this right-hand side. So we've got my negative 15 equals k times negative 6 times negative 1 is positive 6. And what can we do to get k by itself? Divide by 6. So we're going to have our k be this kind of ugly looking fraction of negative 15 over 6. Though both of those are simplifiable because they both divide by 3. So we could make this be negative 5 over 2. You can also leave it as 15 over 6. So then I'm going to come back up to my equation up here. And I'm going to rewrite it with my x, y, and z and my k value that we found. So we know that y varies jointly. So we know together these guys are going to join, my k, x, z. But now we know my k. So we're going to have our y equals that k value of negative 5 over 2 x, z. So then when we're looking to figure out our solution over here, these flowers. Looking at our little pink window over here, I've got x equals 4 and z equals negative 3. So we're going to substitute those in to try and figure out what y is. So we're going to have that our y equals our negative 5/2 when my x equals 4 and my z equals negative 3. Which we can either do by hand, multiplying that out, because we can do that because we're awesome. Or we can type that in the calculator. Negative 5/2 times 4 times negative 3. When we do that, we should wind up with what? What do we get when we type that in? I also got 30. These numbers will sometimes be weird. So these two are really familiar, at least in structure. They're linear equations. They feel very strange in this chapter. The reason these are in this chapter is because directly and jointly aren't our only option. There's one more where it can vary inversely. So this is an inverse variation. So this is our third option for types of variation. So an inverse variation, you can write it in two different ways. You can do it as our x, y equals our constant. Or you could divide both sides by x and get k over x equals y. And you can use either one of these. These are both valid. And it doesn't really matter because literally the only change is this one has the x and y together, this one has a y equals. They're the same thing. I just divided by x on both sides. This is why it's in this chapter as opposed to back with line stuff. So what we're going to do is we're going to look at this one down at the bottom so we can kind of practice this and see what's going on. If m varies inversely as n, so that means we're going to have m n equals some constant k. if y varies, like if we had varies directly, if y varies directly, there's an equal sign between them. If it's inversely, the y and the x are together, or my m and n are together. So then to figure out our k, we're going to use these variables here, or these terms here. So if I know that when m is -4 and n is 6 equals our k. What's our k going to equal? What is -4 times 6? -24. So now I know a little bit more about my equation. I can rewrite this using my k that I know. So in this situation, m times n is going to equal -24. No matter what other values we have, m times n is going to equal 24. So we've been asked to find m when n is -10. 10. There we go. I'm good at words. So I know n's going to be -10, so let's substitute that in. M times -10 equals -24. What can we do to figure out where m is? Or what m is? Divide by 10. Yeah, the -10. So our m is going to be -24 over -10. So we're going to divide both sides by -10. Which you can either do as a decimal, or we can simplify these fractions to get 12 over 5 or 2.4. I don't care if we put it as a decimal or a fraction. But we're going to need to know inverse variation sets up this equation, and we're going to need to know that our direct and joint variations set up these two equations. So we're going to practice with these so we can practice all these forms when they're listed. So we're going to do these three, and then we're going to give you a worksheet where you can practice it more, because this is one of those things that just takes practice to get down. They're not super difficult calculation-wise. It's just the weird words, because math is weird. All right. So we got if y varies directly as x. That means we know this is a direct variation. Direct variation, y equals x times something. That is direct. It's what we're used to. You can do xk, you can do kx. I don't care what order it's in. Multiplying doesn't matter. And we know, y equals 360 when x equals 180. So I know 360 is going to equal 180 times my k. What is k going to equal? It's 2. Divide both sides by 180. It's like when you said it, you had it upside down. 360 divided by 180 gives us 2. So our equation is going to be y equals x times 2, or 2x. So if our question is find y when x is 270, what's y going to be? Yeah. And I'm like out of space here, but I'm gonna write it up here. Y equals 540. So this, it feels less connected to what we've done the past 3 days. It feels a lot more like logic problems. But because of that inverse variation where we technically divide by an x, that's what puts it in this chapter. But it's one of those things that it just feels like we're overcomplicating things. Naturally. So then let's do the next one. We're going to do this varies jointly. So if we know if y varies jointly, I meant for that to be a highlighter, as x and z, y varies with x and z joining up times some number. This set that we know for us to find our k is this trio that's connected. I know y equals negative 16 when x equals 4 and z equals 2. So I'm going to use that to figure out what my k is. Y is negative 16 when x equals 4, z equals 2, and we don't yet know our k. That's what we're trying to find. So we're going to simplify this a little to get our negative 16 equals 4 times 2. That gives me 8 times my k. So what is the k going to equal? Negative 2. Divide both sides by 8. So then that makes our equation for this situation, our y equals x times z times negative 2. And what we're asked to do, our problem here, is to find y when x is negative 1 and z is 7. So we're going to substitute those pieces in. We're finding y when x is negative 1, z is 7, and we still have that k of negative 2. So we have negative 1 times 7 times negative 2. What is negative 1 times 7 times negative 2? 14. All right, our last one up here is we're going to do our inversely. So we know y varies inversely as x. This is the one that's different. This is when we have our y and x together, and it's going to equal that constant. So then the piece we know, I know when y equals 6, x equals 5. So to find our constant, we substitute those pieces in. We're going to have our 6 in for the y, our 5 in for the x, and that's going to equal our k. So what does our k equal? 30. So our kind of generic form of our equation, that's our yx equals 30. And we are asked to find y. Whoa, that's not the highlighter. when x is 10. So we want to know y, substituting in our 10, equals 30. What's our y going to be? And I'm right at the bottom. Yeah, divide both sides by 10. And we get 3. So this is our answer on this one. This was our answer on this one. Most of the time when we have these problems, you will be asked to find your k. So you'll write this part out and to find our solution. So in each of these problems, if we were to have, say, a quiz with a question like this on here, you'd get points for finding the k and points for finding the y. Yes, dear. Yeah, let me write your pass. Okay, so I'm actually going to pass out the last homework before spring break. Oh, snap. Next week, we will be reviewing and getting ready for the quiz. It's on Wednesday. These don't get worse. Okay, so we're not about to toss a whole bunch of letters in here and make these a whole lot of words. They are what they are. That's as bad as they get. Okay? And go ahead and switch that to a nurse class, and I'm going to take that one with you. Who wants to go for a walk? No, 100%, totally fine, and if it's ever that much of an emergency, it's gonna run. I'm gonna have you guys, I want you to help you carry your stuff, and you can take that trash can with you just in case it needs to get on the way. Okay? Alright, now I'm going to pass these out, but you know, like drama, all that jazz.